He's an epidemiologist, he's a clinician trained, but he also is an expert in acoustic epidemiology, which I had not heard of before. It's a wonderful and I think a very important field of medicine. He's done some remarkable work, which we're going to hear about today. So, Carlos, thank you.
Thank you, Luca, and thank you for having me today. I'll try to be brief. And here's first my disclosures. I own equity from Hive Incorporated, and I have received consultancy fees from Hive. So I'll start with a topic that I like a lot. I'll talk about a self-contained world, and the year is 117 after Christ, and this is the Roman Empire. It's 5 million square kilometers. It's between 50 and 80 million people, self-contained around this Mare Nostrum, the Mediterranean, right? And it contained culture, commerce, and everything really needed. So somehow it floated in history for centuries, a bit oblivious to a globe that was around it. And it was guarded by the Pillars of Hercules, and the myth has it that Hercules had used his strength to pull together the ends of the world here in Spain to protect people from going beyond the ends of the world and falling off the cliff. That's one of the myths, right? There's other ones. And he did that because there were dragons and other perils in those uncharted waters. You could be attacked, your ship could be attacked, or you could fall off the cliff. Actually, the mortality among seafarers in this, before the 15th century, was about 50%. 50% of those venturing into the sea would die. And maps were marked with perils, dragons. Some say it's to fill empty space, some say it's to mark actual perils. And the truth is, these markings, hic sunt dracones, there be dragons, were there to prevent people from venturing into danger. But then along came technology. And the compass, the astrolabe, and the quadrant helped seafarers navigate safely through these uncharted waters and apparently miss the dragons that were there. And the Roman world, self-contained, went from the Mediterranean to a globe. And Columbus' first trip turned our world into this, much bigger, and the Mediterranean was no longer the center. Because we're here in Spain, I'm going to talk 1 second about the Spanish Empire and how the columns of Hercules are represented in the Spanish crest, and they have this logo plus ultra that is going beyond. So it became somehow ingrained in the Spanish spirit that you would go beyond the limits of the world, beyond the columns of Hercules, plus ultra. So cough, until now, has been also a self-contained world. It's a major symptom, sign, and disease that we've seen here. And despite major historical importance, even among seafarers, in a world when we can measure any physiological parameter that we can imagine, mostly in inpatients, but increasingly more and more in outpatients, cough is not really used in clinical work as we talk today. Also, in the research setting is limited, and this is because the technology we have is limited in time it can follow. It's limited because it uses human annotators. It's limited because it can be obtrusive. So it's somehow a self-contained world. It's also expensive to use. So this is all things that we saw before can limit use in clinical practice. So then came technology, and artificial intelligence now allows for unobtrusive, privacy-preserving, long-term monitoring of cough that is quite accurate, as I'll show, and it can go for months, and it can run on a cell phone that is for free, downloading it. It can run on a dedicated smartphone, or a smartwatch, sorry. I'll show some of that later. And I'm going to show you the recent results of the validation of Hive. And it was done in 546 hours of continuous audio recording that contained about 4,500 coughs from 23 participants with different diseases. And the gold standard was double annotation by humans with an adjudicator when they were not in agreement. And we enrolled 28 patients. In initially 3 patients, there was a battery malfunction and they had to be removed. But then 2 of them also didn't record more than 20 hours, but at the end, we got 546 hours from these patients, and here are the different diseases. You see the average cough rate was 8.15 per hour. 65% are female, and the majority are US-based. That was a FDA requirement, and you see the diagnosis. And this is the cumulative cough counts in black as humanly labeled over 24-hour period, and that's in the x-axis, and in the y-axis is the cumulative counts. And in red, you see how Hive is performing against human annotators. So Hive is slightly overshooting, and the numbers are here. It's 90% sensitivity, and the false positive rate is about 1 cough per hour. And you see in gray is the dispersion of all the participants, and in red is a summary of all of them. Here is the blunt almond plot that some people prefer. You see the overall bias was 0.23, and you see lower and upper limits there. And here's the performance among all participants. You see in most of them there's great concordance. Sometimes Hive is overestimating the cough rate, sometimes it's underestimating the cough rate, and the proportion can vary according to the baseline cough rate, but it's normally fixed around 1 false positive per hour. So the question with this data is, are we oblivious to a globe? And having a good detailed painting can be beautiful and informative, but then if we ask ourselves what's the context of this, could we be missing something, then we find out, hey, there's more to this. And this question can be repeated. Is there more to this context? Well, perhaps yes. And could we go beyond a week? Could we go a month, for example? Yes. So what's the real context for looking at cough? And this is an example of one of my patients. You see she monitored her cough, and that's the red bars in the bottom here, almost continuously. The interruptions are in white for 6 months. And each dot represents cough counts for 24 hours monitoring. And it's obvious to you that something's going on here. Something's happening in the first 3 months, her cough is going down, and on the second half of the slide, cough is going up. So what's happening? And what happened is that she had stopped smoking here, and a few months later she had relapsed smoking. But then if we had monitored her, let's say a sample every 2 months, if we were unlucky, we could have ended up with something like this. And we think nothing is really going on. And it's the longitudinal signal that brings meaning to this data. And longitudinal, I'm talking 6 months. So what's the real context, and what is better for patients, and what is better for regulators and drug developers? So beyond a single patient example, which is not fair, I think we can explore more, right? And we can follow the steps of modern Christopher Columbus, Matthew Rudd, who's a statistician dedicated now in our team to cough. And he's recently described that cough has a negative binomial distribution. And now, because Hive is available for free in the App Store, we've taken the data from 97 power users. This is people who have monitored at least 20 hours a day for at least 30 days. And we also made sure that this is people that had at least 5 coughs an hour. So in total, this is 58,000 hours of monitoring, 250,000 coughs in this single analysis. And this is the cough distribution of the patients on the graph. And what we see with that is that some people are highly predictable. If you cough for 30 days and I monitor you for 24 hours, I can predict 95% of the time what's going to happen in the other 29 days. Some people are highly predictable, and this is one example. Some people are highly unpredictable. That means that if I pick any 24 hours, I have 38% chances of capturing what's happening in the other 29 days. So I'll be wrong 62% of the time. And if you extend that to the full cohort, this is how it looks. On the left, you see people that are totally unpredictable, and on the right, there's people who are a bit more predictable. However, you could still have bad draws, as there's some red dots in there. Was that a throat clear or a cough? So the overall predictability in this 30-day period, I don't think the QR codes are working, but this was a question for you. And what it is 64%. The median predictability in the whole 58,000 hours of monitoring was 64%. So, as always, as we venture in uncharted waters, there are dragons there, and we have to find a way to sort them or fight them. And one big dragon is privacy. Is this AI capturing my conversations? Am I being protected here? And one good answer to that is on-device processing. That means the device that I'm wearing tracks the audio, and when there's a cough, it captures it, it processes on device, and the only data leaving the device is a timestamp that a cough occurred at 11:53:32. So that leaves out the issue of sending or receiving audio. Everything is processed on device. The other dragon would be what happens with battery life, and people are having a phone. Women normally have it on a bag, men have it on a shirt, they leave it behind. It would drain the battery, people make calls, it would interrupt. So dedicated smartwatch also helps with that. The other issue would be what happens with time that is not monitored. There's silence here. Is this not monitored time, or is it non-coughing time? Well, the smartwatch also has like superficial temperature or other signals that can be used as a proxy for wearing the watch. So is this person actually wearing it? And then probably the most scary dragon of all, the biggest, is what about non-participant coughs? What about the coughs of all the people around me that will come and contaminate my measurements? Well, I think the first question is, how big is this problem? Do we really have a problem with acoustic contamination? And we did a small study with healthy volunteers that were non-coughing, and they monitored for 100 hours in different environments. And you see, walking on an outdoor market, in a restaurant indoors, in a restaurant outdoors, at home with children, in a dense space like a gym, in all of them, there is some contamination. And it goes from 0 cough from other people to 4 coughs from other people in an hour. There's also contamination from false positives. This is other sounds that were not coughs and they were wrongly classified as coughs. Those are red, and they coincide with what I showed you before, the false positive rate of 1 per hour. In blue, you see some go up to 4, some stay at 0, under 1. So after seeing this, you see, well, there is some acoustic contamination. The next question is, how important is this? Can this contamination bias the count of a person? And for that, I'll show you some other data of the FDA validation trial that I showed you before. The human labelers had an opportunity to attach a subjective label saying, this cough sounds far to me, and this cough sounds close to me. This is not perfect, but it's a proxy. And then we use that to calculate the proportion of coughs that occurred according to the human ear, far from the device, and then we calculated a corrected cough rate for each participant and tried to see if these far coughs were actually swaying the estimate cough rates of these people. So the true cough rate, according to human labelers, was 8.15 per hour, as I showed you before. Hive overestimated at 8.40 per hour, as I showed you. And if you correct by saying all these far coughs, they're wrongly captured by Hive, let's take them all out. Well, the corrected rate is 8.11. That means the mean difference is 0.05, so under 1 cough per hour. So if you have a cough rate of 60 per hour, or 100 per hour, 1 cough per hour of other people is unlikely to really change your estimates. If you have maybe 1 cough per hour or 1.5 coughs per hour at 24 or 36 a day, then it could be that another 24 will double your cough rate. But the question here is, why are you wearing a cough monitor? You're coughing once an hour. There are unresolved issues. If you live with a chronic cougher, if your partner coughs, if your family environment, there's children, I have children and they cough a lot. If your roommate is coughing, I am a doctor, I work in the TB clinic. So if I wear a cough monitor, I'm gonna get contaminated. So those still have to be solved. And perhaps there are indications for not using the monitor, or they could be exclusion criteria in clinical trials. And even then, there's options. There's distance-dependent performance. This is something we have explored. The capacity to capture and annotate and classify coughs is reduced the further out from the device this is occurring. We can always talk about a Swiss cheese model in which you take individual filters for male, female coughs, young, elderly coughs, and the holy grail would be the own participant acoustic signature, and you put all these filters one after another to actually come out with a less contamination. There's also other data streams, as I mentioned, there's accelerator, there's speedometer, there's other things that you can use. And finally, if you're really interested in granularity down to 1 cough per hour, and I really need to know this patient has 12 coughs a day, then by all means, add a contact microphone for sure. So going beyond, in summary, 24-hour can limit the predictability of a patient, can limit the clinical usage, and does not really contribute to patient empowering. We see now so many users that come and say, I told my doctor, you see, I'm not crazy. I'm not making this up. Here's my cough. And that's very empowering for them. They struggle with people believing them. AI allows for non-intrusive, privacy-preserved, longitudinal monitoring. And yes, there's pitfalls. We have worked over privacy. We're working on usage and battery life, validation. There's work to do on contamination, but I think I've made a case. This is a dragon that it can be fought. And by all means, fear of dragons should not prevent us from sailing into uncharted waters. If people in the 16th century have said, you know what, I'm going to stay at home until I'm sure all these dragons are not going to harm me, then we would still be bathing only in the Mediterranean. So thank you very much.
Wonderful.